So I'd like to start my presentation with a story about Harry. So Harry, at the time of this story in 2011, was a board member at a local football club, SV Gramsbergen. And Harry in 2011 made quite a shrewd investment. He bought a redundant grandstand from a local neighbouring team called Hoogavan. And I don't think even Harry realised the great investment he'd made at that time, because on closer inspection of the steelwork, they found that it was in excellent condition. And the history of the stand dates back to something like 1976, when it was first erected. So at the time of purchase, the stand was already 37 years old, and Harry bought the stand for €7,000. And as I said previously, they hadn't really realised how good an investment it was, because all the galvanized steel was reused, including some of the smaller components that you see here. And I believe it was a volunteer force was then used to partially dismount the stand and re-erect it. And the total cost at that time for Gramsbergen was about €35,000. And it was estimated at that time that if they'd purchased a new, brand new grandstand, it would have cost €200,000. So quite an initial investment by Harry. So some of these images are the stand being re-erected at Gramsbergen. The main new items that were included were basically the seating and the timber supports for the seats themselves. These are images of the stand in place. You can see the galvanized steel is in excellent condition. Coating thicknesses that were taken at the time showed coating thicknesses of up to 100 microns remaining on the steelwork. And this obviously then not only has the stand already had sort of 37 years of life, the remaining coating ensures many decades of further protection, as well as potentially many further life cycles. And just to emphasize what Gramsbergen did here was, so not only did they contribute massively to sustainable construction, but they also made a massive saving for the club. They saved it in the region of €165,000. So there's an environmental saving and an economic saving that they made here. Now, just to highlight one of the aspects that makes galvanized steel ideal for reuse, and I know many of you may well be aware of this unique characteristic that we have via the galvanizing process, in that during the process you get a series of zinc iron alloy layers that grow. And if we measure on the right-hand side, as you can see, the hardness values of those alloy layers, you do actually find that those alloy layers can be harder than the base mild steel you're trying to protect. So you've got a metallurgically bonded coating that can be harder than the base mild steel that you're trying to protect. And this is a win-win solution in the sense that not only does galvanizing give durability, but it allows your steel to be demounted, transported, re-erected without having any potential damage occurring to the coating. Now, going further with the sort of reuse side of things for steel, last year saw the completion of a major research project via Progress, and this was a EU-funded project with a number of high-profile partners that took part: VTT, SCI, Rookie, and Aachen University. And the whole objective of this project was to devise methodologies for the marketplace, tools for the reuse and design principles for the reuse of steel-based components and structures. And highlighting, let's say, taking you through this flow chart, and this takes us through, let's say, an existing traditional flow. So we assemble our structure on the left-hand side, we use it for a period of time, we deconstruct it, we recycle the steel, and as Bruno mentioned earlier on, that obviously is a big advantage for steel. That then is reprocessed and remade into new elements that we then go through the cycle again. Now, as Bruno mentioned, as far as a circular economy is concerned, recycling is fairly low down in the hierarchy. And the key elements of the Progress project was to take the deconstruction phase and potentially have technologies, methods whereby we can either reuse the whole structure, reuse some of the steel components, or reuse some of the products which may need a bit of further fabrication, and then they go back into the chain. And that obviously takes us further up the hierarchical chain that Bruno mentioned earlier on. In addition to the progress report that was finalised last year, further work has been done in the publication of a recent paper in Structure and Infrastructure Engineering Journal. And this was a life cycle study that was done by VTT Research, SCI, and the Polytechnic of Timisoara in Romania. And what they did was study a typical portal frame structure that was 480 square meters in size. And they did this study over a single reuse phase for this steelwork. And what they found was that there was quite a saving in CO2. So 98 tons of CO2 were saved just via that one reuse phase. And there was also quite an economic saving of something like 24,000 euros. So there's practical examples that have been done as part of the research project. And in addition to that, I'd just like to highlight the recognition within the report of the benefits that galvanizing brings to steel, both in its durability and its robustness. And this is a quote taken from section 9 of the report. Moving on to some actual examples of reuse in action, and this is an example in the UK. It's a portal frame structure that's been galvanized, and aligning itself with some of the key findings within the Progress project is the use of bolted connections. So this is a haunch connection. This has been bolted in this case. Typically, this may well have been in the past welded, and that would obviously limit the sort of reusability of the steel. So you can either reuse it in its exact state, or you can take that steel and use it within a different structure. And this is another example of a connection detail where it's flexible for reuse. So steel galvanizing together offer a win-win solution as far as reuse is concerned. Within our guide, we feature quite a few, as Bruno mentioned, quite a few high-profile contemporary projects where the architects and the engineers have thought through the process and are thinking about reuse already. So this is an award-winning house from Germany. It won House of the Year award in 2020, and it's based on a galvanized steel frame. The connections are all bolted. So if there is any need to either move this house or reuse the steel, it's already there on day one. This is the Leeuwarden Knowledge Energy Centre in the Netherlands. It's actually built on a former waste disposal site. The architects involved with this project were very concerned and wanted to align themselves with circularity. So important choices were made as far as material choice was concerned, and they fundamentally used galvanized steel and timber. And the other critical point here was they wanted quite a light structure. So this is quite a lightweight galvanized steel frame that's been used to create a minimal footprint to the underlying waste site. Again, the connections are bolted. And the other critical thing that the architects wanted to avoid here was they didn't want to use any concrete. So they've avoided concrete altogether. And a final example is, this is the Greenhouse in Utrecht. And again, this has been built on principles of reuse. The architects involved with this project were aware that within the area of Utrecht where this is built, it's up for, in the next 10, 15 years, the area is probably up for redevelopment. So there could be the possibility of this having to be moved. So rather than the whole structure being scrapped, this is being designed on a reuse basis. So this building houses a restaurant, mini conference facilities. They actually grow some of the food that's cooked in the restaurant, and it's all based on a galvanized steel frame. And the other critical point that they considered here was the foundation detailing, and they ensured that the foundation detailing didn't stop the reuse of this of the steelwork. Moving on to a slightly different topic, and this sort of encompasses both reuse, repurposing, sort of remaking, and just focusing on maybe typical products that we may well be aware of that are repurposed at the moment, and that's motorway barrier. So motorway barrier normally is taken down from a motorway when the motorway is being resurfaced, and that tends to be then repurposed within supermarket trolley parks or within car parks. But in 2017, CE Delft in the Netherlands initiated a study whereby they looked at these sort of used motorway barriers, let's say, and found that 67% were suitable for either direct reuse or for regalvanizing. And they took that exercise one step further and did a full life cycle study. And they found that within that study, there was actually a saving of 112 kilograms of CO2 per meter of barrier. And if you took that to an annual figure, the annual saving in the Netherlands would be 26,000 tons of CO2. And if we translate that to a more sort of recognizable figure, that would be 8.3 million car kilometers driven. Now, more recently, what the Dutch Roads Authority have done is, I'm just going to go backwards, sorry, that's gone too quickly. In 2020, the Dutch Roads Authority initiated a stakeholder exercise where they got quite a few bodies involved that were involved with the highway side of things. And they looked at the details of how they could integrate the motorway barrier into a totally circular sort of economy principles. So the beginning of this flowchart details what you traditionally find. You have the virgin barrier, it's in place. And what this study initiated was taking the barrier through a second stage. And what the second stage would involve would be cleaning, selecting barrier that was ready for direct reuse, so it'd go back in use straight away. A further stage was to look at the structural integrity of the barriers, refurbish them or renovate them. And what we mean by that is that the coating, any remaining coating would be stripped, cleaned, and the barriers would then be regalvanized and they'd be back into, let's say, as new condition. Nothing was wasted in this study because there was the final sort of aspect of this was that those barriers that were not reusable at all would be recycled. So they're going to the recycle chain, the steel would be recycled, and any remaining zinc would be recycled. And the final conclusions of the Rice Waterstadt study was that they actually agreed with a lot of the work that was done previously by CE Delft. And what they found was that there was something like a 70% reduction in CO2 emissions, a 40% reduction in environmental costs. And that environmental cost is a model that's used in the Netherlands to monetize life cycle environmental impacts. And the icing on the cake, if you like, was a 10% reduction in operational costs. So that's a very quick overview of galvanizing within reuse. We've got many more examples in our guide. I'd like to just remind you of Harry and his grandstand, and not only the savings that Harry made, but the combination of steel and galvanizing will offer up to 100-year life, and within that 100-year life, there could be potentially many cycles that either that grandstand could be reused or that steel could then also be reused.